Hello and welcome to the Pharmacy Informatics Professor 2020 with your host Armin Simonian. As you know, one of my favorite topics is clinical decision support. And I wanted to do a third episode today, which focuses in on artificial intelligence, one of the areas of clinical decision support, which I think is at the leading edge and where we're headed in the future. So let's go ahead and get started with a presentation that I put together. And today we're going to have some fun. We're going to talk about real life and also the movies and try to go through, look at the roots of artificial intelligence all the way up till today and see where it might fit in the area of health information technology and specifically pharmacy informatics. So I previously gave you this definition of clinical decision support: any computer program designed to provide expert support for health professionals making clinical decisions. Fairly simple and straightforward. And we went through the CDS types, clinical order checking categories, and then reference information order sets and rules. And at the end, I had cognitive computing or artificial intelligence. There's a lot of names for this: machine learning, artificial intelligence, deep learning, cognitive computing. These are all included under that category. So when we're using artificial intelligence, what we're trying to do is simulate the human thought process in a computerized model. So we're going to use all this data that we have out there. We're going to, on the spot, analyze it, and then let the machine kind of look for patterns, learn on its own, apply some probability to figure out if it's confident or not making a decision or making a recommendation. And some of the challenges, as we've talked about with cognitive computing, is developing these algorithms, teaching the computer how to think for itself, and then verifying that it's doing a good job. So let's talk a little bit about real life and the roots of artificial intelligence. And I'm going to go back to Garry Kasparov, who was a chess world champion back in 1985 at the age of 22. And for 15 years, he remained as the world champion. So an incredible mind when it comes to playing chess. Now in the picture, we have IBM Corporation and something called Deep Blue, where they were starting to use artificial intelligence and apply it to the game of chess. So they had a project that was started. IBM Corporation is known as Big Blue. And so this computer system, this artificial intelligence system that started as Deep Thought, ended up being called Deep Blue. And what they did is they challenged Garry Kasparov to a chess match, and they wanted Kasparov to play the computer. And lo and behold, with the very first match, the computer, or the very first game, not the entire match, the computer won that first game. But then Kasparov went on to win 4-2. IBM went back and did some upgrading and kind of studied what Kasparov had done and put some new logic into the system, and came back again and challenged Kasparov to another match, and this time the computer won. So it was the first time where a computer kind of applied thought processes and was able to beat the world chess champion. Okay. With cognitive computing, these are computers that reason, think, deduce, and possibly become self-aware. And I want to talk about the movies a little bit, because going back many years, 50 years, people have been fantasizing about computers that become self-aware and kind of take over the world. And it starts in 1968 with a movie called 2001: A Space Odyssey. And these are space travelers that are on a ship that has a computer, HAL 9000, and that computer eventually decides that for self-preservation, it's going to take over the ship and kill the humans. I have a definition of heuristic here, so when you have time, you can go back and read all of the intuitiveness, the stereotyping, the educated guessing that we associate with computers that can think for themselves. So the computer HAL was able to recognize speech, facial recognition, lip reading, art appreciation, a lot of different things which 50 years ago did not exist. In 1984, we had the Terminator. You guys are probably familiar with this movie. And in the Terminator, you have Skynet. Skynet is the computer system that becomes self-aware and then tries to kill all the humans again. I don't know why they keep trying to kill the humans, but they see the humans as a threat. And so the whole movie is kind of based on this idea of artificial intelligence and the computer becoming self-aware. One of my favorite movies of all time, The Matrix in 1999, went a step further and the computer system took over the world, and instead of killing all the humans, when the humans tried to block the solar power that ran the machines, they decided to use humans as little batteries and hook them up and in sequence get the energy from the humans, controlling their minds. And again, we have computers that basically become self-aware and dominant and take over the world. So people have been thinking about these concepts for a really long time and have put them in the movies, even though they weren't a reality. But now with IBM Watson, we'll take the next step with IBM. This type of computer that can think and is becoming self-aware is really becoming a reality. So what are the things that HAL had way back in 2001 Space Odyssey that Watson has in terms of how to communicate with the outside world? So in order for a computer to be like a human, it has to have speech to text. So it has to recognize speech and be able to turn it into text. And then also take text and turn it into speech. Visual recognition, meaning it has to see images. And then it has to have insights, so concept insights. You know, our language is kind of strange. We have a lot of idioms and acronyms and things like that. And so the computer has to be able to interpret those. And then it has to do real-time data analytics and probabilities and weighting so that it can decide if the conclusion that it's coming to is really the probable, likely, correct conclusion or not. In 2011, we had the Jeopardy champions come back and play Watson in a game of Jeopardy. I was fortunate enough to go to a screening of Jeopardy about a year ago and was able to interact a little bit with Alex Trebek. Unfortunately, he recently passed away, but he was an incredible person who had this incredible show. And there were champions that had won a lot of games and a lot of money, and they decided to put them up against the Watson computer system. And as you can see, Watson was able to listen to Alex Trebek, hear the question or the answer, formulate the question based on its database, which it had every book ever written, this huge bank of computers with a huge amount of data, and then programming to be able to interpret the answer and come up with the question. And if it felt confident, let's say 75% confident that it had the right question, then it would ring in and ask the question. But if it didn't, it would not ring in. And you can see that it won handily against the former champions. Lee Sedol is an expert world champion in the game Go, which is a very old game. And in this game, it's basically pebbles that are placed on a board, and the person is supposed to capture as much territory as possible. And they decided to put Lee Sedol against AlphaGo, which is a computer system that plays Go. And in the end, the computer actually won against the champion, and the champion cried. But the champion did not cry because of the loss. The champion cried because he had tears of joy and wonderment that the computer had somehow figured out moves that nobody would ever do, that were considered low probability moves, but the computer thought in the strategy of the game that it would be effective to win the game, and it did work out. So here we have computers who are thinking, the computers are thinking and beating the champions in chess, in Go, in Jeopardy, in other areas. Now the next step for Watson, they said, okay, if the computer can figure all these things out, why don't we put it to work in drug discovery? So they actually have been acting as consultants in this area, using the computer to help develop new therapies. They also had an endeavor with Memorial Sloan Kettering to see if the computer could take information about our patients and come up with a diagnosis of cancer and the best way to treat that cancer based on all the evidence in the world that was in the computer banks. So this was, I'm going to call it an experiment because it did work to a certain extent, but it wasn't totally successful. But I think they were a little bit premature in the whole development of AI, and possibly if they redouble their efforts and go back to it, they might be able to have some success in the area of analyzing patient charts, applying this artificial intelligence to the area of healthcare. Now, AI is great, but it's also considered dangerous in a lot of ways. So we've had a lot of very smart, genius people, successful people come out and give their opinions about AI. They support AI, but at the same time, they're telling us to be careful, cautious, because we could have the situation with the Matrix or the Terminator where the computers go out of control and basically take over. So this is something in these very smart people's mind that could be a reality. This is a recent article by Alan Flynn, and he talks about artificial intelligence, the application to pharmacy. And his abbreviations here are AI for artificial intelligence and ML for machine learning. And he's saying that there's a lot of places where they can apply this. And I agree. Getting back to the main topic of today, clinical decision support, I think that there's a lot of potential. This is kind of the cutting edge of where we're going with pharmacy informatics, applying artificial intelligence to clinical decision support. You know, as pharmacists, we have to review every medication order and verify it prior to the patient receiving the first dose. And we look for a lot of different things, drug-drug interactions, allergies, the right dose, the right route, the right frequency. All of these things come into play in your mind when you're verifying an order. And do we trust our computers now, today, to auto-verify our orders for us? Do we trust them enough that we could say, okay, every prescription that the computer reviews and gives a thumbs up is okay? I don't think we're there yet, but I think this is kind of our next frontier, and we're kind of heading in that direction. So with that, I hope you found this episode interesting, and it was a little bit stimulating in terms of thinking about AI, past, present, and future. And if you gained something from this video, please like it and subscribe to my channel. I'll thank you for that. And in the meantime, stay safe, stay healthy, look after the health of others, and I'll start working on the next video, which should be on the topic of medication safety applied to automation. And in the meantime, take care. We'll see you next time.